Okay, so we are going to do some right triangle stuff. And this is about 5.5. Numbers 6 through 8 is what someone requested. So we're going to do that. We already did some of it over here. And this all is going to help us find these things. So let's see. What did we find? X is 7.72. And because I want to use that, I'm just going to write it over here just so that in case we do need it. I don't know if we're going to need it, but it's just good to know. So this is asking us for AD, this length here. And what do you see in this picture? The classic Miss Johnson question. How many triangles do you guys see? Very good. You should see 3. One right here, one right here, and then one right here. So notice I didn't say how many right triangles do you see, because literally I know this and this are right triangles. And now knowing a little bit more, I know that this is not a right triangle. BCD is not a right triangle. So if I ask you how many right triangles there are 2. And your brain should get more comfortable with like being able to ignore parts of this picture and focus in on whatever you need. So if we want to find AD, I'll call it Y for now. If I wanted to find Y, this length here, right? What should I use? Should I use the triangle on the left, the triangle on the right, or the big triangle? The triangle on the left, the triangle on the right, or the big triangle? What do you guys think? Yeah. And if you don't know, if you're like, I don't know, Miss Johnson. So the way I figure it out is I ask, who is Y exclusively part of? Right? Y is part of the big triangle, but you'd have to add this section over here. So it's exclusively part of this right triangle. So my brain is going to focus in on this right triangle. I'm going to ignore this stuff on the left-hand side. And I'm going to look at this and I'm like, oh my gosh, it's my friend. Very familiar 30, 60, 90 triangle, right? Where if I know this is 6, I know this is 2 times that. So this is 2 times 6, which is 12, right? And then this down here, anybody remember how long this side is? Like in a 30, 60, 90 triangle, it's x, 2x. Very good. This is going to be x root 3, or in this case, 6 root 3. So this is 6 root 3 feet. Never anything that I would ever go to Home Depot and say, can I have 6 root 3 feet of blah, blah, blah? That doesn't make any sense because, you know, I would actually give him a decimal approximation of it. Right. So is everybody comfortable with my right triangle on the right hand side? Is everybody okay? So this is that 30, 60, 90 triangle. Big piece of advice. If you don't have this memorized, not a big deal. Just make sure you have like a sheet, like a reference sheet of all the things you would know. Maybe like the 30, 60, 90, the 45, 45, 90, SOHCAHTOA. Today we went over law of sines, law of cosines, and the area formula for a non-right triangle if you didn't have the altitude. So keep, maybe like that would be a really good reference sheet, right? Okay. So then it says find BD. Oh, find the whole thing from B all the way to D. From B all the way to D. Okay. So what I would do is, okay, so let's see. I already know this part, but I don't know this part. Okay. And I can't use the Pythagorean theorem on BCD. You should know why, right? Because it's not a right triangle. So what I'm going to do is I'm going to find AB and I'm going to call him, I don't know, W, right? I'm going to call him W so that I can find him. So if I was looking for W, what equation could I write? There's several. What equation could I write for W? So the first thing you want to ask is, well, which triangle should we be looking at, Miss Johnson? Right? Which triangle should I be looking at? Any ideas? Okay, yeah, I'd use the left triangle. So give me an equation in the left triangle that would help me find W. Now, if you don't know how to like determine which equation to use, my suggestion is that you write all of them. Write sine, write cosine, write tangent of B. So I'm going to write that over here. I'm going to write sine of 51 degrees, cosine of 51 degrees, and tangent of 51 degrees. Okay. And based on this, this will tell you which of the three are good to use. So if you haven't used this, this is so toa, right? Right? So toa. So sine of 51 is going to be opposite over hypotenuse. Opposite over hypotenuse. So that's going to be 6 over 7.72, which is like, I don't know, it's just an equation, but it doesn't have, oh, it's not catching up to me. Hold on, I thought it would catch up by now. There it goes. So this equation is true, but it doesn't have a W in it, so it's not going to help me. Oh, I just figured out I could have also used the Pythagorean theorem too, huh? So then, yeah, cosine is W over 7.72. So that's a possibility. Oops. W over 7.72. And last but not least, tangent is going to be 6 over W. Okay. 6 over W. And so whichever one you wanted to use, the Pythagorean theorem, cosine, tangent, it doesn't really matter. So I'm actually going to use the cosine 51 because the W is on top. When W is on bottom, there's like one extra step, so I won't use that. So this means that W is equal to 7.72 cosine 51 degrees if I solve it. And then I'm going to come in here with my, I don't have a Desmos open yet. So I'll come in here with my Desmos calculator. You should be telling me, Miss Johnson, don't forget to change something, something, something. Right, 7.72 cosine 51 degrees. And then I'll change this to degrees. Boop, boop, boop. Okay, so there's 4.858 is my answer. So that's about 4.858. So I'm going to take this over here to my other, this is 4.858 feet. So in order to find the whole thing, I'm just going to add those two numbers together, right? To find the whole thing, I'm just going to add those two numbers together. So I'm just going to put it up in front. If you add it back here, most likely it won't, like cosine won't grab the, it won't grab it, but just, you know, to be safe, I'm going to put 6 square root 3 in front and add it to that. So the whole thing is about 15.251. So this is 15.251 feet. So that is what I found for BD. 15.251. Ms. Johnson, I notice you keep putting feet and stuff. I do, because when they give you units to use, now you're supposed to be using units everywhere. Okay. And then it kind of triggers to me that this is a side, not to be confused with an angle, right? Okay, last but not least, now they want you to find the area of triangle BCD. Now, because we worked on that one formula, you could also use that formula here, right? If you wanted to. Okay. In fact, one of the things I suggest you to do is find it one way and then find it the other way. So the first way that I'm going to find it is by using the formula area equals half times base times height, which in this case, the base I'm going to use is going to be this guy, 15.251. And then my height is going to be that 6 feet. And then I'm hoping this is going to be equal to that other formula that I'm going to use in a second. So bringing my calculator back here. Here's my base, right? So I'm going to multiply this. I'm just going to keep this. You guys are going to laugh because I'm just going to keep this thing out here. So this is going to be my base. So I'm going to say 1/2 times base. And then I'm going to say times my height, which is 6. So that's about 45.752 feet squared. 45.752 feet squared. Okay. Because we just learned that one formula and this is not catching up to me at all. So hopefully it does. There it goes, I think. Maybe not. Because of that, I really want to check my other formula. So I'm going to write it down, but it seems like it's not catching up to me. If you remember, it was like half AB sine C. So our formula, and I'll write it up here for now because it's seriously not catching up. 1/2 AB sine sine. It's not going to take sine right there, but C. For some reason, because it's thinking AB is sine C. So maybe I'll use different letters. I'll use CA sine B. There you go. So whenever you're choosing these, C and A are two sides. There it goes. B is the included angle. B is the included angle. So because I know angle D, they gave me angle D. It is 30 degrees. I'll use this one. So I'm going to go 1/2 times this side times this side, sine this thing here, right? So that's the formula I'm going to use. So in case you want me to write this down, I'm going to go with, in our case, our specific case here, I'm going to go with 1/2 of, let's see, BD. Okay. It's just like notation's sake. It's not going to show it. Just give me a second. Oh, wow. This is like taking forever. Okay. Well, while I wait for that, I will show it on my calculator. There it goes. All right. So just a little side note, when I put BD like this, I'm saying the length from B to D. If I put a hat on him, it's now talking about the actual segment. No hat means the length of B all the way to D, also known as 15.251, right? So I could just put that in there. So 1/2 times 15.251 feet. CD is 12 feet. And then sine of 30 degrees. So I'm going to plug that all into here. So let's see, 1/2 of 15.251 times, I'm going to put a little times here just in case, times 12, and then sine of 30. Ms. Johnson, are you sure you used degrees? I did, if you can kind of see this part. So my answer is 45.75. Oh, this is my same answer. Notice any trends here? So during a test, Ms. Johnson's always going to try to find different ways to verify her answer because, like I copy things wrong all the time. So do you. So if I really truly did it, these two almost like independent, they're not really independent. They're kind of interrelated, but these two independent ways of finding the area of this would be validated. All right. Thank you for listening. Have a great day.